Hello and welcome everyone to this webinar. In this webinar, we're going to be considering how to become a data engineer. This is an important question and something that I hope to give you more clarity on as we go through this webinar. The reason this is important is because we want to, you want to leverage some of my knowledge and some of my experience having taught data engineers pretty extensively. Not just data engineers, but all sorts of data scientists, other people who are trying to make that switch and that jump from software engineer to data engineer, or some people who are trying to go from a data analyst to a data scientist. I want to pass on some of the knowledge and some of the experience of why people fail at doing this. And I want to prevent that failure. More importantly, people will come in with incorrect expectations or what they're trying to do, and I want to help you with that. So a little bit about me. Once again, my name is Jesse Anderson. I have been teaching data engineering and data engineering skills for the past probably 8 years now. And I have taught pretty extensively. I've taught all around the world. I know many of you are in the London and England area. I've taught pretty extensively there. The value that that brings is that I've not just understanding what's happening in the UK market or the EU market, but what's happening all around the world, because I'm guessing some of you are from all over the world and coming to this. So I really want you to benefit from that knowledge, and we'll see what sorts of things are important for people to see. So here's our itinerary for the next 45 minutes. A bit of housekeeping before I get into this. I'll be going over this material for the next 45 minutes. We'll have about a 15-minute Q&A period. If you experience some sort of problem with your webinar where you can't hear or something's happening, you can either put a question in the question box, or usually people can refresh and it will start working again. Once again, in that 15-minute period at the end, I'm going to be answering your questions. So as you see something that you have a question about, I really do encourage you to ask that question so that you can leverage my knowledge and see what you need to do there. So here's our itinerary. First, we'll talk about data engineering. We'll talk about what data engineering is, what a data engineer is, what a data scientist is. Then we'll talk about 5 common mistakes that people make as they try to transition from to a data engineer. And these are just mistakes I see repeated over and over again. And I really want to share these because these will save you so much time and money in as you try to switch careers there. And finally, I'll share some next steps for you. This is important because you'll need to, if you're going to be motivated coming out of this, or perhaps you're in the middle of making that switch, you need to double check that the next steps are right for you. So without further ado, let's talk about this. To start off with, let's talk about what a data engineer is. And a data engineer, by my definition, is a data engineer is someone who has specialized their skills in creating software solutions around big data. Put a different way, a data engineer is a software engineer who has specialized in big data. And that software engineer is actually key there. There are several different definitions of data engineer out there. Some of those data engineers have a definition of kind of a DBA or a data wrangler. In my opinion, and this is specific to big data, that isn't the correct definition for data engineer. In this case, we actually need a data engineer. And next, we have the definition of a data scientist. So a data scientist is someone who's augmented their math and statistics background with programming, and that's a key there, to analyze data, create applied mathematical models. This is a crucial difference, and it's a difference that I've seen not be really talked about and really be misunderstood by both companies and those people who are starting to learn. If you see the post there at the bottom, you see that minified URL, that points to a post for Riley that goes deeply into what is the difference between a data engineer and a data scientist. And as you start to decide on your journey of which way you're going to go, understanding these differences is crucial. So if you are coming, depending on your background, if you're coming from a software engineering background, more than likely you're going to be going to a data engineering role. If you are coming from much more of a mathematical, much more of a statistical background, you are going to more than likely go into a data scientist role. Now that programming is key there. So you remember how I emphasized that programming for the data scientist? This is, in my opinion, one of the biggest differences between for example, a data analyst or a business intelligence person, that programming is key. And generally the programming language for data science is by and large Python, to a certain extent Scala. Those are the two main ones. For data engineering, it's primarily Java and and Scala or Scala, and to a much lesser extent Python. Now there is one more definition that I have on there, and you may hear me use that and see that throughout this, and that's a DBA. DBA, I kind of paraphrase and group several different titles all together, and I just kind of call it shorthand DBA. These sorts of titles are SQL focused in nature. So these are things like DBA, database administrator, ETL developer, SQL developer, those sorts of titles. This is an important distinction because usually the people who are doing the SQL focused tasks or jobs are more focused on SQL as the technology and SQL as the language. And as you can see from that data engineer, a data engineer is actually somebody who is a software engineer who actually programs well. And we'll talk a little bit more about that later. So this is an important distinction and often a stumbling block, especially for those coming from that DBA and SQL focused background. To that end, what is data engineering? So a data engineering team is the one that creates data pipelines. When I work with companies around the world, especially, there's a misunderstanding about what each person and team does. And at its very core, a data science team is there to consume data pipelines. Stress on consume. Data scientists are not great at creating data pipelines. They're not great at doing the data infrastructure that needs to happen there. This is the role that a data engineering team or data engineer does on the team. They are responsible for creating that data pipeline so that it can be consumed by the rest of the organization. And what sorts of technologies do we use for this data pipeline creation? These are various big data technologies. So just as an aside, everything that I'm talking about in this webinar is big data focused. I don't really deal with small data. I only deal with big data and big data technologies, and that's the theme throughout. So these big data technologies are things like Apache Spark, Apache Kafka, Apache Hadoop. You may have heard of them before, but these are just a few of the technologies that we're using to create these big data pipelines. And this understanding of these technologies is important, and we'll talk about this more later. But this is what the data engineering team at its core is doing. They are taking and creating the data pipelines so that they can be consumed by the rest of the organization. That includes the data scientists. That includes perhaps other software engineering teams. That includes data analysts, business intelligence. There's all sorts. But at the hub is the data engineering team. So a data engineering team itself is actually made up of mostly data engineers. And you'll notice I use the word mostly. That is because a data engineering team is not solely made up of data engineers. We'll talk about this in a bit more depth later, but it's multidisciplinary. What that means is that on a data engineering team, you may have a DBA or maybe two, but the vast majority of the team is made up of data engineers. And this is a crucial difference and an often different starting point that we'll talk a little bit more about later on. So why should you even think about becoming a data engineer? I'll share some of my experience having seen this for a number of years. There definitely was a misunderstanding in big data about what each person's skill is. If you look at the majority of early teams, even teams that are starting right now in big data, or not even starting, but continuing on with their big data projects, they're often getting stuck. And there's this realization that I've been writing about and really been pushing, that data engineers are crucial to big data projects. So there's this realization, not just at the team level, at the data engineering team level, but it's also a realization at the higher parts of management, the CXOs, the VPs, and that sort of thing, that they're able to now understand that data engineers are absolutely required for big data projects to succeed. And now, given that realization, now companies are really trying to hire for data engineers. And so, as a direct result of this, there are very few data engineers out there. They're in really short supply. So many of my clients, as they're trying to find a data engineer, they're battling with a bunch of other companies trying to hire for that same position, all having realized that they need data engineers. Previously, that focus was definitely on data scientists. If you kept up with the industry and you read about the industry, you saw the sexiest job of the 21st century is data science. And that led a bunch of people to go into data science and get data science jobs. Now there's this definite realization that, yes, we need data scientists, but we need data engineers. I don't have it on this slide, but I've talked about it in that link that you saw previously, that that post on data scientists versus data engineers. The ratio of data scientists to data engineers should be 2 data engineers to 5 data engineers per data scientist. Once again, a ratio of 2 to 5 data engineers per data scientist. That means that there should be significantly more data engineers on a team or in a company than there are data scientists. And what's happening right now is that the inverse of that is happening. There's more data scientists to data engineers. So companies are going to need to hire in order to rectify that mismatch and that mismatch of ratio. So that kind of shows you, here's the need. There's a high demand, low supply in the market. As a direct result of high demand, low supply, data engineers, at least in the US, are making 20,000 to 60,000 per year more than a non-specialization. That means that compared to a software engineer of similar background, similar years of experience, they're making 20,000 to 60,000 a year more in the US. And once again, that's due to that high demand, low supply. High demand for people who can do this, not many people that can do it. And as a direct result, companies are having to compete with each other in order to have these people come work for them. When that happens, there is a much more of a back and forth and a much more negotiation and trying to lure these data engineers in. And that's where that 20,000 to 60,000 per year more comes in. What's another reason why I would strongly suggest you specialize? I believe that in software engineering especially, we should be specializing more. Personally, I spent most of my career being much more of a generalist, and I kind of prided myself on being a generalist. The issue there is that I could have been making significantly more had I specialized better. So eventually, as later on in my career, as I started to specialize even more in distributed systems and client server, and finally going significantly more into the big data side, it was only then that I really started taking advantage and seeing how good that specialization and how much more I could make as a direct result of that specialization. So I also believe that the specialization of data engineer has a good longevity to it. You might have heard the term barrier to entry. In other words, how easy or how difficult is it for somebody to become a data engineer just off the street? It's pretty difficult. I've taught pretty extensively around the world and at many different teams, many different students. Frankly, it's not everybody who can become a data engineer. there are differences and there are abilities that are difficult for people to make that jump, frankly. So it's not everybody who can do it. And that's what I saw out there, is that barrier to entry. If not everybody can do this, you have a good barrier to entry, in that you won't wake up one day and somebody can use a WYSIWYG tool or a GUI tool to create something. So just to kind of contrast that, many years ago, I did a lot of web work, and I started to see that the WYSIWYGs, the WordPresses of the world were really taking over. And as a direct result, there's a less demand, less need for web people, and there's less excuse me, less usage of them. That was something that I saw, and I got out of it. Had I stayed in there, I probably would have received a lot of price pressure, received lower salary. What you want to do is actually the opposite. You want to specialize and realize that, and find a barrier to entry for that specialization. Now let's talk about the five most common mistakes I see people make when they're trying to become a data engineer. The first one is not understanding complexity. This is key and crucial and incredibly important. It was actually so important that I wrote an entire post there that you can see on the bottom for O'Reilly. And I wrote that because I saw that management, I saw that individuals, I saw that teams in general did not understand the complexity increase for big data. In that post that you see there, my hypothesis or my thesis is that big data is 10 times more complex than small data. So most of you are coming from a small data background and trying to get into big data, trying to become a data engineer. And this is important because you're coming from a small data background. You probably haven't ever dealt with data or things of this scale. And I see these issues kind of reflected or manifested all the time, where somebody will ask me a question and they'll not really understand either the complexity or the scale involved with big data. Uh, Oftentimes you'll see somebody who thinks that 10 gigabytes is big data, for example, or they think 100 gigabytes for that matter is big data. Those are all incorrect. And this is why companies need data engineers to tell them, no, you're better served doing X rather than trying to use Hadoop for that. This is a key and crucial thing. To kind of expand on this and help you understand, I teach management classes as well. You guys teach them all over the world. And as part of that, I try to make sure that the management understands the difference of big data, and more importantly, that some of these questions can only be answered by a qualified data engineer, somebody who actually knows what they're talking about. So I try to make sure that that management at all levels knows what is important and why it is important to have a data engineer either on their team or have an entire data engineering team, depending on the size of the organization. So why is this? What are some reasons why big data is so much more complex? It's because there are 10 to 30 different technologies that you're going to need to know. And this isn't just, hey, there's a framework that's pretty simple and you could pick up in a day. These 10 to 30 different technologies are all pretty complex. They're all distributed systems. They're all non-trivial in understanding and learning. This is incredibly important for you to understand. Also, you're now dealing with distributed systems. You're now dealing with processes that are running on several different machines, all running at once, all running in a concerted way. This is non-trivial in its complexity. And I say that having taught pretty extensively. It is a difficult thing for people to wrap their head around. Another issue is that projects aren't well documented. So these, for example, Spark, there may be books about Spark, but the actual usage of it, the actual trying to do it, trying to use it to solve a problem, there aren't some sort of cookie cutter example out there. And you can't just look at documentation. You will have to read that. You will have to solve that and figure it out. So once again, I would strongly suggest you read that book, or excuse me, read that post on complexity and big data. Another common failure is that people will think that beginner skills will get them a job. In other words, they think that by watching a video on YouTube and being able to spout some of the basics about let's say the 4 V's of big data will get them a job. That isn't true. Employers need data engineers. They need qualified data engineers, but they're not going to settle for beginners. And this is because they've been burnt by beginners before, frankly. Uh, I talk to a lot of hiring managers all over the world. They are gun shy about hiring, or maybe gun shy. Maybe gun shy doesn't translate. They're leery of hiring beginners because they've hired beginners before, and that beginner is not able to do the job. And another key and important thing, a group of beginners. If you're on a data engineering team and all of you are beginners and there's no veteran on the team, you will likely fail because you don't have the background and don't have the veteran direction to say, here is what you should be doing. There are all sorts of beginners out there, and these companies actually need data engineers who can create these pipelines. This is key and important. So once again, if you think you can get by with just some cursory knowledge, can't be further from the truth. Another common issue is confusing expertise and experience. So experience is how long you've been working professionally at something. On your resume, you would say, I have used technology X for some amount of time. Now, expertise is different. Expertise is your skill in that. So kind of to the previous slide, I was talking about beginners. So the question may come up as, how would somebody with no experience actually get a job as a data engineer? It's by showing expertise. And you do this by creating an awesome personal project. And in my courses and in working with people, I actually help them create this awesome personal project that actually shows their expertise and shows their abilities. This is key and important. You can't just walk into an interview and show nothing on your resume. You need to be able to show, I did this, I showed this with a personal project, and this is how my students get jobs. You might be thinking, well, this is just Jesse's opinion. When I go into a company, I make sure, and I actually ask the hiring manager, if you had a student come in with demonstrable experience or expertise, would you hire them? And the answer resoundingly is yes. They will hire people who can show expertise. And this is how you deal with the lack of experience. You show your expertise, and then you can get the experience. However, you have to put the effort in, and you have to have created that awesome personal project as a requisite. Another issue, some people think that they can just learn data engineering over a weekend. That can be further from the truth. Some people think that it's easily done. Some people think that it can be done with a bunch of beginner videos. So oftentimes people will tell me, I'll ask people, how do you plan to learn big data? Oh, I'm going to watch some videos on YouTube, and I'm going to go through a Udemy class or a Coursera class. The issue with the Coursera classes, they're generally okay. The issue with the Coursera classes is that they're basically beginner stuff. It's a bunch of beginner materials, and if your desire is to learn to understand beginner things, hey, that's fine. But if your desire is to get a job, you need completely different materials at that point. You actually need materials that go to the intermediate and advanced levels of the technology. This is why I see people failing so often to get a job. They aren't able to make that leap from these beginner things, and they think that they can use some beginner videos to get advanced, and that just takes a lot of time. Some people can do it, mind you. The vast majority of people cannot do that. I also try to pass on that it's going to take 2 to 6 months of concerted effort for you to learn these technologies and become a data engineer. Another common foible there, or common mistake, is that people will think that you only just need to learn Apache Spark. A data engineer is just somebody who knows Spark and just sits around in Spark all day. Here's the problem. You saw that big data, the complexity of data engineering is 10 to 30 different technologies. If you just understand or know one of those technologies, then you're going to have a much more difficult time getting that position because you just put Spark on your resume. Here, I can do Spark. But that isn't what companies need. Companies need people who can understand how Spark, and Spark is just one part of it, what else you need. So I have a post there that's called The 3 Components of a Big Data Pipeline. I would strongly suggest you read that because I kind of go through why people fail because they only think they need Spark. And I talk about the other parts that are necessary for a data pipeline. When you work with data pipelines, when you create a data pipeline, you need several different technologies. One of them is Spark, but you'll need others. And this thought that I just need to learn Spark is unfortunate because you just put that in your resume. I talk to these hiring managers. You remember how I just talked about how I talk to the hiring managers. I say, what would make you hire somebody? Another common complaint as I talk to those managers, those hiring managers, is they say, oh yeah, I interviewed them. They only knew Spark. They only had a beginner level of Spark, and that isn't enough. I need technologies, these other technologies. I need somebody who understands the rest of it in order to create a data pipeline. Key and crucial misunderstandings like these are the ones that keep you from getting a job. Usually when people try to get a job, you won't get that feedback from the hiring manager that says, we didn't hire you because of X. You rarely get that sort of feedback. And by me sharing this with you, you can start to see, oh, maybe you've tried to do this already. Maybe you've tried and failed. And now perhaps you're seeing some of the reasons why you're trying and failing. So now let's talk about some next steps. I'm going to talk about a few common ways or common patterns I've seen people try to become a data engineer. The first one I'm about to talk about is, if you're a software engineer, how would you become a data engineer? Usually, software engineers are using Java, or more pedantically, JVM languages. There's a reason for this. In big data, the vast majority of the technologies are written in Java, or a JVM language, more pedantically. For example, Spark is written in Scala, which runs on a JVM, a Java virtual machine. And as a result, the best support and the best usage of it is to use a JVM-based language, Java, perhaps Scala. And a very common question here is, let's say you don't know Java. What should you do? Well, then that's assuming that, once again, you know a different language, perhaps C#, perhaps fill in the blank, perhaps Python. Your knowledge of syntax in big data is not going to be your challenge. When people ask me that, I generally should tell them, you need an intermediate level knowledge of the language. You don't need a bunch of design pattern knowledge. You don't need a bunch of tons of information or knowledge about Java internals and that sort of thing. They're helpful, definitely, but they're not so requisite that somebody would turn you down. What you do need to know is a few of you need to know how to make classes. You need to understand the class structure. You do need to understand how things work and how that works. Of all the various keywords, you'll need to understand what a transient variable is, for example. But other than that, as far as difficult things, it's relatively straightforward. The difficulty in big data is not programming; it is systems creation. And usually people will misunderstand what's difficult about data engineering. Programming is usually the comparatively less difficult part. Usually your more difficult part is, how do I create a solution for this problem? In other words, that system creation. What technology should I use? What what is this and that I should do? This is what's difficult about data engineering. Uh, Other things, you will obviously need to understand and learn the technologies. And if it isn't very clear already, I will restate it again. It's not just learning one technology. If you're coming in from, let's say, a web application background, for 99% of your career, you've been able to get by with the same three things. For example, you might have been able to get by with Java, a relational database like MySQL or Oracle, and perhaps a web framework, a web application framework like, um, uh, let's say, Tomcat or something like that. And you've been able to get by even as you switch companies, even as you worked in different industries, for example. You've been able to use those same three things. Well, here's what's different about big data. You are going to have to learn 10 to 30 different technologies to be able to choose the right tool for the job, because as you do different use cases, as you work with different technologies, you will have to use those in different ways and in different settings, different configurations. The difficulty, once again, is not so much on the programming side. The difficulty is understanding how to create the system, how to create that data pipeline. Another common transition for people trying to switch careers to big data is from a DBA, or as you'll remember, that's my kind of shorthand for a SQL-focused person. So how does a SQL-focused person become a data engineer? Some titles that this might be is DBA, ETL developer, SQL developer, data warehouse engineer. And that data warehouse engineer is important as another important title. In my opinion and experience, a data warehouse engineer is not a data engineer. This is because the need to program is crucial and important and requisite. It is not a it's not a nice to have. It is requisite for you to know how to program. And this is the very first step. This is the very first crucial step for the SQL focused positions to do. They need to get intermediate level programming skills. And another issue there is that the programming is just one part. You heard me talk a lot about the difficulty of creating data pipelines, the difficulty of creating that systems. This is, in my experience, working with DBAs and teaching DBAs, this is their most difficult part. And this is because there aren't sample architectures for you to copy. There isn't a book out there that says, given this scenario, here is what to do. The reality is that I don't think that we'll see that even 5 years out, perhaps 7 years out. We won't see these sample architectures that everybody copies. So you've more than likely seen sample architectures where a business or a vendor will say, here's our architecture, here's our recommended architecture. The issue is that that architecture may or may not be right for the use case. I don't have it linked there, but there's a post that I have on my website called "This is Useless Without Use Cases." I would suggest you read that if you're not quite following what I'm saying here. But in a basic sense, we need our use case to be very well understood before we can start choosing technologies, using technologies, and creating a system. Until we've understood that use case, then we can't do that. So kind of circling back to that sample architecture assumes certain use cases, which may or may not be present, useful, done in the same way as that sample architecture. That is why it is incumbent upon you as a data engineer to figure out if that's the right architecture or the right use case for what you're trying to do. Crucial, important, and this is a big reason why I've seen teams fail, that they don't understand the differences in technology to use the right thing. So crucial, crucial, you absolutely have to learn, you have to understand the technologies. And I won't sugarcoat this for those of you who are coming from this. This is a pretty difficult path. I won't lie there. It is difficult not just because of the programming, but because of the systems creation. There are ways that I think that a data DBA can interact with a data engineering team better. One kind of half step that you might think of doing is learning some of these technologies, understanding this better, and fulfilling more of a reporting and perhaps analytic role and a schema role on the team. But it is definitely a more difficult path to be a data engineer on the team. So given all this information, what should you do? These are my general recommendations for you. The first one is to not cheap out in your training. That may not be as common framed in Europe. Basically, don't choose the cheapest way, the free way to learn about these technologies. I can't stress this enough. Watching videos on YouTube will get you to perhaps beginner levels. You might understand it at just enough to be dangerous, but that isn't what companies need. This isn't how people get hired as data engineers. They don't hire a data engineer who's watched a few videos on YouTube. They hire a data engineer who actually understands this and can create a data pipeline. That's the base metric that companies use to hire. So if you just try to do the free and cheap route, you won't achieve that level. Another common thing is for people to try and read books. Books, the big data books, I've read a lot of them. I do the technical reviews for O'Reilly on many of them. The books are good. That said, they're good for people who are already in the industry, who already have a pretty good background. It's really difficult, in fact, if not impossible, for most beginners to pick up a book and really read it and understand it and be able to create something. I say this having interacted with a lot of people who've tried to do this route. It's just not a very successful route, quite frankly. So please don't cheap out on your training. You actually do need to spend money. You need to spend time on this. So next thing, you want to find a good source of training. The training that you want to look for is, if your goal is to become a data engineer, you look for people saying that they actually became a data engineer from that. And this is a difference that I see in the training industry just in general. If you go look on a Coursera or you look on a Udemy training course, usually they'll say 5 stars, learned a lot. But is that your goal? Is your goal to 5-star and learn a lot, or is your goal to become a data engineer? The two goals are very different, but it gives you clarity in what you need to do and where you need to learn from. You need to be seeing on the testimonials or the people saying and reviewing, I got a job from this. I learned enough to get a job. And that's a key difference. As my students have gotten their first jobs and even moved on, I'm incredibly proud of them. So they not only got their first jobs, but they've also moved on to some of the most prestigious companies out there. I was going through my students and where my students are in preparation for this, and my students are at Apple, they're at Uber, at Cloudera, let's see, Google, and let's see, was it Stitch or Lyft? It was something like that. So they just didn't get a job. They got eventually, with their work, with their hard work, with their training, they were able to get the top jobs in the Bay Area. So a crucial thing there. Look for in their testimonials people saying they got a job based on this. Next thing, you need to plan the right amount of time. If you think that you can turn this around in a weekend, you're wrong more than likely, with 99.9% certainty. You need to understand that it's going to take a month, 2 months, 3 months of concerted effort and time to do this. I say this because I see people really waste their time. They think they get disheartened after spending 2 weeks instead of really planning out and saying, "Oh, I actually need to spend several months on this in order to do it." Next thing I have people do is to think about that awesome personal project. That awesome personal project is key. This is kind of your business card. This is your resume. In fact, it's better than your resume. It shows your personal ability and love of data, frankly. It shows your ability to to create a data pipeline from end to end. And here's what's crucial to the management and to the people hiring you. It shows your personal ability. Somebody else didn't create this project. You weren't part of a team that created this. It shows what you personally can do so that when they hire you, this is what they're going to be able to expect out of you. Crucial and important. Has to be awesome. There are some key and important parts to that. And in my class, I actually go through this and devote an entire chapter to personal projects because I see the importance of this and how it can be done. Then the final thing is to decide on the best way to market yourself. Quite frankly, software engineers and technical people just in general are absolutely terrible at marketing themselves for positions. Absolutely terrible. For me personally, it was a real turning point in my career and in my abilities when I was able to go through and market myself better through better marketing materials, better resumes, better personal projects. And what I was able to do, I was able to reverse the dynamic. Companies started coming to me rather than me coming to companies. It was an incredible and marked difference in my career and quite honestly in my finances. So really do think about that. As much as you may hate the marketing person that you work with, there is a certain panache that you should learn, and that, in my opinion, all technical people should be starting to learn how to market themselves better. So that said, we're going to turn it over to questions. I hope that you've had lots of questions for me and that I just haven't been able to see them, obviously. But what's going to happen now is Rachel is going to start reading your questions for me, and I will be answering them. In the meantime, here's a little bit more about me. You've seen my website as well. You can follow me on Twitter. You can link with me on LinkedIn. And there's my YouTube channel. And as part of my YouTube and part of what I do in terms of helping people, I'm known for using physical objects to teach really complex distributed systems questions. For example, I show how Kafka works with Legos, how MapReduce works with playing cards, that sort of thing. And it helps people get a good understanding and realize that they're actually so good and so effective that they've been studied. There's going to be a published paper on these methods later at some point. But the paper has been accepted for publication, where a professor in Florida studied it and published the results of it. So with that, Rachel, go ahead and start reading some questions, please.
Really great webinar, Jesse. Thank you so much. We managed to get a lot of questions. Some of them you have answered throughout the talk. So I'll ask them anyway, and then you can obviously just give a quick answer. The first one being, do you still think it's relevant to study Java?
Yes, it is. So there's a post that I have on my site. You may be thinking about, should I learn Java? Should I learn, if I'm a Java programmer, should I learn Scala? And there's a post I have up on my site where I talk about a data engineer, in my opinion, does not need a dynamic language. In other words, a data engineer is creating software that is repeatable, They're not necessarily trying to do analytics and ad hoc analytics. And that's usually where a dynamic language like Scala is necessary. It's definitely necessary for data scientists. They need to be able to ad hoc, do some analysis, do something like that with code. But for data engineers, we're creating repeatable data pipelines. I don't believe that we need dynamic languages like Scala. And I kind of go into that in that post. I think it's called Spark and Java, yes, they work together. And the core reason why I don't like people learning Spark and Scala at the same time is that it's cognitive overload. Somebody cannot learn both at the same time. I've seen way too many people fail by trying to learn a programming language and a really complex technology. It's just cognitively not able. You're just cognitively not able to do that, frankly. So what I highly recommend people do is you take your knowledge of Java and then learn the technology like Spark, and then decide if you need something like Scala. Decide if you need the dynamics of that. And I think that for the vast majority of data engineering teams, they don't need that. And the vast majority of data engineering teams I've dealt with are not Scala specifically. All right, next question.
Perfect. So next question. What environment do you suggest to play with Spark? Creating your own PySpark notebook?
So in this case, your environment to play with, I would definitely try to create a virtual machine. So for my class, for example, I create a virtual machine that has everything on it. It has Spark, it has Hadoop. This way, when you're playing around with things, you're not spinning up, for example, an EMR cluster and having to pay for that. So that's one way of doing it. This person is obviously coming from the Python background because they're talking about PySpark. In the community, there is PySpark, but usually what data scientists are doing, they're using a Jupyter notebook, or perhaps they're doing a Databricks notebook as well. But you'd have to pay for that Databricks notebook, depending on what levels you're using it at. So my suggestion is to use that virtual machine. That virtual machine is put together so that you can productize and query by yourself. When I work with a team, when I work with a data engineering team especially, or data science teams, I try to make sure that they have isolated resources, and so they have their own isolated virtual machine. That means carving off a representative part of the data, having that small enough so that it could run in that virtual machine. And then once they do the ads at scale, or the full load test, or the true, or perhaps full model training in this case, then you go to the cluster. As you're trying to become a productive data engineer, or perhaps data scientist for you need to understand that running how much data to run on is important, because that factors into your turnaround time. If you take 15 minutes to run on some data, that's way too long. You need to cut that data set down into much smaller pieces so that you can do turnaround times for processing, or perhaps for a test, into a much shorter period of time. Next question.
Would you recommend any courses or qualifications to help improve data engineering skills such as Spark?
Yes, you're going to receive after this webinar a link to my course. I say that with all humility, that I think my course is pretty good. It's the one that I've taught people in very similar situations to yours, and they got those. They became data engineers, and I would say more importantly, as time went on, they became data engineers who were at the top companies. So you receive that, as well as I'll be passing on a promo code for you to get 33% off because you attended today. I think my course is different, or maybe just in a general sense, why I think this is different. My course is called Professional Data Engineering, and I think that's a specific difference because I don't teach you Spark. I teach you how to create pipelines with Spark and how to integrate Spark with other things. And this is what companies want. Part of the reason why I called it professional data engineering is I'm trying to teach you the skills to get a data engineering job. I'm not teaching you a technology so that you can put a technology on your resume. This is why you saw those common mistakes before. This is part of the reason why people fail at this, is they think that data engineering is the act of learning Spark or the act of learning a single technology. Data engineering is the act of creating data pipelines that use Spark, that use this and that technology. But that is the key. That is the main difference. And part of the reason why I call it professional data engineering, it's how do professional data engineers create this, create these systems. I also talk about, for example, unit testing. This is one thing that a professional data engineer does. They unit test their code for fast turnarounds. And these, I'm one of the few, really honestly, few people talking about how do you unit test Kafka? How do you unit test Spark? How do you unit test MapReduce, for example? All key. This is what professionals do. Next question.
On Udacity nano degrees, similar to Coursera?
Yes, nano degrees are show time spent or time served, kind of. It doesn't show expertise. In my experience, and this is one of the questions I ask those hiring managers. I say, given what's out there, nano degrees, certifications, this and that, what do you actually look for? Or what's important to you? Certifications are not important unless they're government, quite frankly. The only time I've really seen certifications be either talked about or used or needed is if it's a government contract or if it's a consulting body shop, where there's a consulting shop that has 2,000 people, and they say of those 2,000 people that 200 are certified with Cloudera certification or some micro degree or nano degree, and it really shows no expertise, quite frankly. There's only one certification that I've seen that really shows any sort of expertise. There's Cloudera's data engineering, where you actually have to code. In order to pass that project, or excuse me, that certification, you have to code. Those are the only certifications that make any difference. A nano degree means that you went through some videos and you have time served. It doesn't show that you can create a data pipeline. It circles back to the importance of a personal project that shows what you did. It's not hello world. Let me expand on a personal project. One of the common mistakes I see people do is that they create a personal project that's basically hello world, where my personal project is word count. And if you know anything about big data, you know that word count is the very basic, the very first step. And so they put that in front of the people and they say, here's my personal project and it's word count, or maybe it's a slightly modified word count. And that's quite frankly worse than doing nothing. It basically shows, oh, okay, well, you modified word count. Do you even know what you're talking about? This is such a bad sign. So really key, really crucial is to show true skill there. It's not just a word count. It's not just something simple. It is, I spent an appreciable amount of time, and that is what hiring managers want. So there's two things that you want to show for your personal project. One is the source code, and two is it working. You would want to come in during an interview. When I work with my students, I say, when you send your resume, you also send your GitHub and say, here's my personal project. Here's a GitHub with all the source code on it. They may not look at it at that time, but when they're in the interview with you, better believe that they're going to look through that code and you better believe that they're going to want to see that pipeline running. This gives you a job, seeing the pipeline running, seeing you have actually created that and the expertise required for that. Next question.
Personal projects are usually toy solutions to a problem, but since the distinguishing feature of data engineering is being able to handle big data, that won't work. So what kind of personal projects do you suggest?
I would disagree with needing big data for a personal project. So a personal project, what you'll want to do is you'll want to, in your code, make sure that you don't write anything that doesn't scale, for example. An example there is you write some code that expects everything to run in a single process. That's an indicator that you don't understand big data and you created a scalability issue, for example. That said, showing it working on a small data, a smaller amount of data is fine. People won't ding you for that. What you do need to show is that you understand the technologies and you're using the technologies correctly, immaterial of the size or amount of data. That said, if you truly want to go full on and you want to do something with a large data set, by all means, knock yourself out. You don't have to pay for a huge cluster anymore. You could just use the cloud technology. As I mentioned, we were talking about that, being able to show that running. It could just be an SSH session, for example, or you SSH'd into a VM in the cloud and saying, okay, here's my cluster running, and it's processing all of Wikipedia. If you didn't know it already, on both AWS and Amazon Web Services and on Google Cloud, they have large data sets. They have all of Wikipedia. They have dumps of GitHub. There's some sizable data sets. If you want to do that, by all means. But that is a question that I've asked those hiring managers. They won't ding you for having smaller amount of data or operating on a smaller amount of data, as long as you didn't mess up in your coding, where you're expecting something to, you're not expecting a shuffle sort, or you're doing your reduce incorrectly. Other than that, you can do it on small data. If you really want to pay some extra money, by all means, spin something up in the cloud. Next question.
I'm just finishing a Bachelor of Science in Computing and IT with a focus on software engineering. I need to get a job and earn some money before I can afford a specialist data engineering course. What sort of entry-level job should I look for to tide me over whilst I do the extra training and build up my skills?
What I would do if I were you is I would try to find a company that has a training program. At least in the US, and I've hit a few companies in Germany doing this. They will have a certain amount of money set aside per employee for training such like this. One of my customers, for example, is a financial company in the US. They have $2,000 per year allocated for each person to do extended learning. And what you do there is the people will come in. You just have to get a sign off from your manager, and and in this case, you'd be able to get the specialization, you'd be able to get the specialized training, and have your company pay for it. Usually the key there is to convince your manager that it's either related to your growth or related to what you're trying to do. And in many cases, the manager is okay with that, because in this case, it is software engineering. So I would look for a company like that actually has a learning. Usually, it's called a stipend or something like that, and how much that is. But it's becoming more and more common for companies to have that available. I think we have time for one last question, Rachel.
Just this one. Where does the engineer-scientist ratio, 2 to 5 data engineer per data scientist, come from? For small companies that deliver a customer-facing data product, could be prioritized over building infrastructures. Is the ratio good only for certain types of companies or certain stage size? Happy to read that again because I know that's quite a long question.
No, it made sense. So in that question, where did it come from? If you read that post on that you saw early on, it was called developers or data scientists versus data engineers. That comes from right there. In there, I say the ratio is 2 to 5 to 1. Where did I get that? It is from my own experience. It is from me actually asking a bunch of people that I know who are either consultants or running data engineering teams. And it also comes from a Google paper. In the Google paper, they don't stipulate that ratio, but what they do say is the vast majority of data science, or in other words, the machine learning part, the actual creation of that model, is negligible in comparison to the data engineering, the data infrastructure required to create that. So your question was also around size of teams and industries and that sort of thing. I've seen this industry-wide. I don't see a difference in industry. And as far as the size of the company, if you have a company that's super small with a very small team, and you have a bunch of data scientists going at this, the reason I say, or a major reason why I say get yourself some data engineers, is because the data scientists, quite frankly, are not the right team or the right person to do the data engineering. They either can't do it or they do it super slow. For example, it may take a data scientist to do some relatively simple computer science tasks, could take them a week to do, which may take a half day for a data engineer. It's just there's no comparison there. There's a post that will be coming that I've written that hasn't been published yet that's going to go even deeper into this. And it's going to talk about why a data scientist is not a data engineer. The person who asked this question, if you link with me on LinkedIn, say that you were part of this webinar, I will share that with you so that you can read that in more depth. I've been sharing it privately until it gets published. Well, I think that ends our time together.
Yes, thank you so much. Thanks everybody as well for asking all your questions. I'm sorry we wasn't able to get through them all, but as Jesse mentioned, his Twitter's on there, so if you want to ask him a question directly, I'm sure he'll be able to find the time to answer. Thank you.
Thank you again for spending some time with me today, and thank you again to MarketInvoice and Rachel for putting this on.
Have a lovely evening all. Bye.